Algebraic Reasoning, Chapter 1.1, Exercises 11 through 20. I'm going to work out a few of these problems, 11, 12, 17, and 18. For questions 11 through 16, determine whether the sequences shown are arithmetic or geometric sequences. Then write a recursive rule and an explicit rule. This word here, arithmetic, looks like arithmetic, doesn't, spelled the same way. But it's arithmetic because you're using the word as an adjective and not as a noun. Arithmetic is a noun. Arithmetic is an adjective. And so we look at the terms, and we're going to look at see how much they change from one term to the next. And to get from 1 to 8, well, you're going to have to add 7. And we add 7 here to get from 8 to 15, add 7 to get to 22 from 15, and add another 7 to get from 22 to 29. So we will say arithmetic sequence. And why do we call this an arithmetic sequence? Because the terms, as we go from one to the next, have a common difference. So that's a definition of what arithmetic sequence is. Next says, write a recursive rule and an explicit rule. Well, what we have is, for a recursive rule, we say, you start out with your first term, which we call a sub 1. This little subscript number means that's the first term, and we just write down what it is. It's 1. And then a sub n equals a sub n minus 1 plus 7. So that means if we find any term here, we can just take that term and add 7 to it. So like if we want to find like first, second, third, fourth, fifth, if we want to find the value of the fifth term, we take a sub 5, for instance. We want to find, we'll take the prior term, which is 22, plus 7 equals 29. So that's a check. So that'd be a recursive rule. Now for the explicit rule, I'm going to go ahead and write this, kind of put this as a table. So we're going to have n comma a sub n. That's what we're going to do. We're going to call it, we're going to say 1, 2, 3, 4, 5. And then opposite those, we have 1, 8, 15, 22, 29. And we already observed that these things are going up 7 every time. So what we want for an explicit rule is to find where n equals 0. Well, to find that, since we're going up by 7 every time here on the right, what's going to happen to get to 0? Well, we're going to have to add 7 to a certain number to get 1. Well, if we take 1 minus 7, we're going to get negative 6. So negative 6 is our starting value here. So we can write this explicit rule is a sub n equals a sub we'll put the number of times, so we'll say 7n plus -6. We'll say -6. And to test it out, we can just take any term. If we want to say a sub 3, a sub 3 should be 7 times 3 minus 6, which is going to be 21 minus 6 equals 15. Is that correct? Check. So this will be our explicit rule for number 11. So yes, arithmetic sequence very good. Let's go on to number 12. Kind of taking a little time, a little glitchy. Okay, here we are. We see that we're increasing like we were on number 11, but we're not increasing at a constant rate here, are we? Because this would be 6 minus 2 is 4, but 18 minus 6 is 12, so that's not going to work. I'm just going to go straight over to a table here and put in n a sub n, and our first term, put 2, 3, 4, 5. The value of our first term is 2, then 6, 18, 54, and 162. And what we're doing is what times 2 equals 6? So it's going to be times 3. So let's say times 3. And if we go over here and notice all of these, they're all going to be times 3. 6 times 8 is 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. So we'll say geometric and why? Because there is a common ratio and not a common difference. Okay, well, so that's that part of it. Now we're going to go for recursive rule. And again, recursive, the start of it is really easy. You just say our first term, a sub 1, equals whatever it is, 2. And then what else? Well, our common ratio is 3, so we'll say a sub n let me get this. Let's put a comma here. A sub n equals a sub n minus 1 times 3. Okay, so that's going to be, and we can test whatever we want. So if we're starting out at 2, but if we want to get 54, we want to get our fourth term, we take a sub 3, which is, we'll say a sub 4 should be equal to 18 which is a sub n minus 1. I'll put a sub 3 times 3, which equals, in this case, 18 times 3 equals 54. Check. So this will work as our recursive rule. Now for explicit rule, we really do it like this. A sub n is equal to we put our first term 2 times our common ratio, which is 3, to the power of n minus 1. And now you can just check it out. This is just a form of doing this. You can see this in your exponential equations too. This is going to be our initial value. And this will be our common ratio. And then we can test it out by saying a sub, I don't know, let's try 2. We should get 6, right? So our answer for that is going to be 2 times 3 to the power of n minus 1. That's going to be times to the power of 2 minus 1, which is going to be 2 times 3 to the first power, which equals 6. Check. So this is going to be our explicit rule right here. I'm boxing in. So that's it. Good luck on those other problems 13 through 16. We're going to go straight up ahead to the next section, which will be 17 through 20. And frankly, this is, I believe, quite a bit easier because you just be able to plug in. And so the first 4 terms of the sequence, okay, we want n, 1, 2, and then a sub n is going to be over here. So our first term is going to be a sub 1, so that's going to be 9.5. And we can use either way to get it. It looks like the answer is going to be a sub 2 is going to be 3 plus 6.5 times 2. It's going to be 3 plus 6.5 times 2 is 13 equals 16. And really, we are adding 6.5 every time. So if we take 16 plus 6.5, what do we get? Well, 16 plus 6.5, I think it's going to be 22.5. Is that right? Yeah. Then we can, to that, add another 6.5. We get 29. And you can test it out always with one of these. We can say a sub 4 should be, okay, 3 plus 6.5 times 4. Well, 6.5 times 4 is 26, so 3 plus 26 equals 29. Check. So answers would be 9.5, 16, 22.5, and 29. Okay, number 18. We have this time we have a common ratio and not a common difference. So we're going to go n, a sub n. Well, we know that for a first term, we just get right here 3. And we should be able to see that our common ratio is 4. So R equals 4. So if we take 3 times 4, 3 times 4 would be 12. Okay. And then we continue that pattern times 4. 12 times 4, 48. And then one more time times 4. And let's see, 48 times 2 is 96. 96 times another 2. We should get 192 is what we should get here. And we could just try it out with the explicit rule here. We would have a sub 4 should be equal to 3 times 4 to the power of 4 minus 1, which equals 3 times 4 to the power of 3. Well, 4 to the power of 3, 4 times 4 times 4, 64. So we have 3 times 64, which is going to be equal to 192. Check. So our correct answers to this one are going to be 3, 12, 48, 192. And that would be it. Good luck on all these other problems, and thanks for viewing.